question 1 of this exercise, we have to find the roots of all of these given quadratic equations by factorization. So the way we factorize a quadratic expression or a quadratic equation is by splitting the middle term. So how do we do that? So suppose that we have a quadratic equation ax square plus bx plus c equal to 0. So what we have to do to factorize is we have to split this middle term bx or this coefficient b into two parts, let's say p and q, such that p plus q is equal to b, the sum is equal to b, and p times q, the product, is equal to a times c. So this is how we have to split the middle term, and this is what we're going to do in this question. Okay, let's begin with part 1. So in part 1, the equation is x square minus 3x minus 10 is equal to 0. So what we have to do now is we have to split this middle term minus 3x such that the coefficients are, the sum of the coefficients is equal to minus 3 and the product is equal to 1 into minus 10 or minus 10. So the two such numbers whose sum is equal to minus 3 and whose product is equal to minus 10 are minus 5 and 2. So we'll split the middle term minus 3x as minus 5x plus 2x. So let's do that. So we will get x square minus 5x plus 2x minus 10 is equal to 0. And now this equation can be factorized. So from the first pair of terms, x square minus 5x, let's take out a common factor of x. So we get x times x minus 5. And then from the second pair of terms, let's take out a common factor of 2. So we get 2 times x minus 5 equal to 0. And hence this quadratic equation can be factorized as x minus 5 times x, this x plus this 2. So x plus 2 is equal to 0. And now we have factorized the quadratic into two linear factors. We can now easily write the roots of this equation. The roots of this equation are x equal to 5 and x equal to minus 2. So let's write the roots here, 5 and minus 2. So that solves part 1. Now let's do part 2. In part 2, the equation is 2x square plus x minus 6 is equal to 0. So to split the middle term, we have to find two numbers such that their sum is 1, the coefficient of x, and their product is 2 times minus 6 or minus 12. So those two numbers are 4 and minus 3. So we'll split the middle term x as 4x and minus 3x. So let's do that. So we will get 2x square plus x, which becomes 4x minus 3x. This is how we split the middle term, and minus 6 is equal to 0. Now we can factorize this equation. From the first pair of terms, we can take out a common factor of 2x, and that leaves us with x plus 2. And then from the second pair of terms, we can take out a common factor of minus 3, and that leaves us with x plus 2 once again. And now we can take out x plus 2, and that leaves us with 2x, this 2x minus this 3. This is equal to 0. So now we have factorized the quadratic into two linear factors, and now the roots are quite easy to write. So the roots are the 0 of x plus 2, so x is equal to minus 2, and the 0 of 2x minus 3, so x is equal to 3 by 2. So the two roots of this second quadratic equation are minus 2 and 3 by 2. So that solves part 2. Now let's go to the quadratic equation in part 3. So the equation in part 3 is root 2x square plus 7x plus 5 root 2 equal to 0. So to split the middle term 7x, we have to find two numbers whose sum is equal to 7, the coefficient of x, and whose product is equal to root 2 times 5 root 2, that's 10. So two numbers whose sum is 7 and whose product is 10. Those two numbers are clearly 2 and 5. So we'll split the middle term 7x as 2x plus 5x. So let's do that now, and we will get root 2x square plus 7x gets split as 2x plus 5x, and then we have 5 root 2 equal to 0. Now from the first pair of terms, root 2x square plus 2x, we can take out a common factor of root 2x, and that will leave us with x plus root 2. And then from the second pair of terms, we can take out a common factor of 5, and that will leave us with x plus root 2 once again, and this is equal to 0. And now we see that this x plus root 2, this factor is common, so let's take this out. So we get x plus root 2 times this root 2x, so root 2x plus this 5, this is equal to 0. So we have managed to factorize the quadratic into two linear factors, and now finding the roots is quite straightforward. The roots will be x equal to the 0 of this first expression, so that's minus root 2, and x equal to the 0 of this second expression, which is minus 5 by root 2. So these are the two roots of the quadratic equation in part 3. So let's try. Question 2 of this exercise says solve the problems given in example 1. And in example 1 we had represent the following situations mathematically, and we had these two situations, two word problems. So we had to represent those mathematically, and then now we also have to solve and find the unknown in each case. So let's start with the first part. So the first part says John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start with. So let's say that this is John. So I always like to make these drawings because it helps think quite clearly. So let's say this is John and this is Jivanti, and initially they have 45 marbles together. So let's say that John had x marbles, which means that Jivanti would have 45 minus x marbles, because the total of their marbles should be equal to 45. Now both of them lost 5 marbles each. So now John will have 5 marbles less, so he will have x minus 5 marbles, and Jivanti will have 45 minus x minus 5, which is 40 minus x. So Jivanti will have 40 minus x marbles now. And now the problem statement says the product of the number of marbles they have now is 124. So this means that the product of this number and this number should be equal to 124, and this fact is what will enable us to form a quadratic equation in x. So we have that the product of x minus 5 and 40 minus x, this should be equal to 124. So let's simplify this and see what we get. So expanding the product on the left hand side, we have x times 40, so that's 40x. Then we have x times minus x, that's minus x square. Then we have minus 5 times 40, that's minus 200. And then we have minus 5 times minus x, so that's 5x. This is equal to 124. So shifting all the terms on the left hand side to the right hand side, we will get minus x square will become x square. Then we have 40x and 5x, that's 45x. When it goes to the right hand side, it becomes minus 45x. And then minus 200 becomes plus 200. So 200 plus 124 is 324. So x square minus 45x plus 324, this is equal to 0. And this is the quadratic equation that models the given situation. Now to solve this quadratic equation, what we will do is we will use factorization. So we will split the middle term And to split the middle term, we have to find two numbers whose sum is equal to minus 45 and whose product is equal to 1 into 324 or 324. So we have to find two numbers, let's say P and Q, whose sum is equal to minus 45 and whose product is equal to 324. So if you think a little bit about the factors of 324, we see that 324 can be written as 18 into 18. It can also be written as 9 into 36, and 9 times 36, 9 plus 36 is 45. So the two numbers P and Q, whose sum is equal to minus 45 and product is equal to 324, are minus 36 and minus 9. So you can split this middle term minus 45x as minus 36x minus 9x. And now the quadratic equation becomes x square minus 36x minus 9x plus 324 equal to 0. And now we can factorize it and solve it. From the first pair, take out a common factor of x, so we get x times x minus 36. And from the second pair of terms, take out a common factor of minus 9. So now we will be left with x minus 36, and this is equal to 0. Now we have this common factor of x minus 36, so let's take that out. So we get x minus 36 times x minus 9 equal to 0, and from here we can get the two roots of the equation. So the two roots are the 0 of the first term, so that's x equal to 36, and the 0 of the second equation, so that's x equal to 9. So our answer is that John had 36 marbles and Jivanti had 45 minus 36 or 9 marbles. So we can write the answer like this: John had 36 marbles and Jivanti had 9 marbles to start with. But the other solution is also possible. If I take, instead of taking x equal to 36, if I take x equal to 9, then John had 9 marbles to begin with and Jivanti had 36 marbles to begin with. So because we are not told who had the higher number of marbles or who had more marbles, both of these answers will work. So what we can say at the most is that the two of them had 36 marbles and 9 marbles respectively, and we don't know which one had how many. So the two answers possible are John had 36 and Jivanti had 9 marbles, or John had 9 marbles and Jivanti had 36 marbles. And we can verify that because the original number of marbles are 36 and 9, if both of them lose 5 marbles each, then the new number of marbles are 31 and 5, or 31 and 4 actually, and the product of 31 and 4 is equal to 124, which is what is given to us in the problem statement. So the answer is correct. In part 2, the problem statement says a cottage industry produces a certain number of toys in a day. The cost of production of each toy was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. So the unknown is the number of toys produced on that day. So let's say that the number of toys, let's represent the number of toys produced by x. And now we have to form a quadratic equation in x. So what information are we given in the problem statement? So the problem statement says the cost of production of each toy was found to be 55 minus the number of toys produced in a day. So we can write the cost of production per toy. This will be equal to 55 minus the number of toys produced. Now, so this will be equal to 55 minus x. So you have to be a little careful in writing this expression, because I have seen many students write this as x minus 55 instead of 55 minus x. The problem statement clearly says the cost is 55 minus the number of toys. So 55 comes first and then x comes. Okay, now the other piece of information that the problem statement says is that on a particular day, the total cost of production was rupees 750. So the number of toys produced was X, the cost per toy was 55 minus X, and the total cost was 750. And this means that the product of the number of toys and the cost per toy, so X times 55 minus X, this should be equal to 750, and this is how we get our quadratic equation. So let's simplify this, write it in the standard form. So we have 55x minus x square on the left side equal to 750. Let's take the terms on the LHS to the RHS. So we get x square minus 55x plus 750. This is equal to 0. Now to solve this quadratic equation, we will split the middle term. To split the middle term, we have to find out two numbers whose sum is equal to minus 55 and whose product is equal to x squared, the coefficient of x squared times the constant term, so 750. So by the way, I missed this 0 here, so this is the equation. So now we have to find out two numbers whose sum is minus 55 and product is 750. So a little thinking will show you, if you think about the factors of 750, you can see that 750 is 25 times 30 and the sum of 25 and 30 is 55. So the two numbers which you need to split the middle term are minus 25 and minus 30. So you can split the middle term as minus 25x minus 30x. So let's do that. So we will get x square, and then we split the middle term minus 55x as minus 25x minus 30x, and then we have plus 750 equal to 0. And now we can factorize this by taking out the common factors from each pair. So from the first pair we can take out x, so we get x times x minus 25, and then from the second pair we take out minus 30, so we get minus 30 times x minus 25. This is equal to 0. Or now we have this common factor of x minus 25. Let's take that out. So x minus 25 times x minus 30, this is equal to 0. And now we can find the roots of the equation. So the roots are x equal to 25, which is the 0 of the first linear factor, or x equal to 30, which is the 0 of the second linear factor. So the number of toys produced on that day could be either 25 or it could be 30. If the number of toys produced was 25, then the cost per toy would be 55 minus 25 or 30, and the total cost would be the product of these two numbers, which is 750. On the other hand, if the number of toys produced was 30, then the cost per toy would be 55 minus 30 or 25, and once again the product of these two numbers is 750. So both the answers work. The number of toys produced on that day could be either 25 or it could be 30. In question 3 of this exercise, we have to find two numbers whose sum is 27 and whose product is 182. So let's say that one of the numbers is x. Now because the sum of the numbers is 27, the second number must be 27 minus x. So because the sum of the two numbers is 27, we can assume the two numbers to be of the form x and 27 minus x. Now we are also told that the product of the numbers is 182, and this means that x times 27 minus x is equal to 182, and this gives us a quadratic equation in x. Let's write it in the standard form. So we get 27x minus x square on the LHS. This is equal to 182. Now let's move all the terms on the LHS to the right hand side. So we get x square minus 27x plus 182 equal to 0. So this quadratic equation models the situation given to us in the problem statement. Now to solve it, we will split the middle term minus 27x by finding two numbers p and q whose sum is equal to minus 27, which is the coefficient of x, and whose product is equal to the coefficient of x square, which is 1, times the constant term, so that's 182. Now to find these terms, you will have to think a little bit about what factors 182 has. So 182 can be written as 13 times 14, and we can see that 13 plus 14 is equal to 27. So this means that the two numbers which we need to split the middle term are minus 13 and minus 14. So let's split the middle term using these numbers. So we get x square minus 13x minus 14x plus 182 equal to 0. And now we can factorize this quadratic equation easily. Now from the first pair of terms, let's take out a common factor of x. So we get x times x minus 13. And from the second pair, we take out a common factor of minus 14. And once again, we get x minus 13. So this is equal to 0. So now we have a common factor of x minus 13. So let's take that out. So x minus 13, and then we are left with x minus 14 equal to 0. And now we can see that the two roots of this equation are x equal to 13 and x equal to 14. So if x is equal to 13, then the first number is 13 and the second number is 27 minus 13, which is 14. And if if we take x equal to 14, then the first number is 14 and the second number is 27 minus x, or 13. So in both cases of the roots, we get the same pair of numbers. We get 13 and 14. So the answer is that the two numbers whose sum is 27 and product is 182 are 13 and 14. In question 4, we have to find two consecutive positive integers, the sum of whose squares is equal to 365. So by consecutive, we mean one after the other. So if the smaller integer, or if the first integer is equal to x, then the larger integer will be the one right after x, and that is equal to x plus 1. Now we are told that the sum of their squares is equal to 365. So this means that x square plus the square of x plus 1, this should be equal to 365. And from here, in question 5, the problem statement says the altitude of a right triangle is 7 cm less than its base. If the hypotenuse is 13 cm, find the other two sides. So let's first draw a figure that will help us visually model this situation. So let's say that this is the base of the right triangle, and let's say that this is the altitude. So let me draw it perpendicular to the base, so like this. And then let's say that this becomes the hypotenuse. So if I assume that the base of the right triangle is x plus or x centimeter, then the altitude is 7 centimeter less than the base. So the altitude will be x minus 7 centimeter. So if I assume the base to be x centimeter, the altitude becomes x minus 7 centimeter. And now we are also told that the hypotenuse is 13 centimeters. So I have the base length in terms of x, I have the altitude length in terms of x, and I have the hypotenuse, the numerical value of the hypotenuse. Now if I apply the Pythagoras theorem to this right triangle, I can write an equation in x. So basically the sum of the squares of the base and the altitude should be equal to the square of the hypotenuse. So we should get x square, the square of the base, plus x minus 7 whole square, the square of the hypotenuse of the altitude. This should be equal to the square of the hypotenuse, or 13 square. So now we get a quadratic equation in x, let's write it in the standard form first. So we get x square plus the square of this binomial will be x square minus 14x plus 49, and this is equal to 13 square or 169. Now let's collect the terms. So we get x square and x square, that's 2x square. Then we have minus 14x, and then we have 49 minus 169 on the LHS, so that is equal to minus 120, and this is equal to 0. Now we can take out the common factor of 2 from all the terms, so we get x square minus 7x minus 60 is equal to 0. Now this is a quadratic equation in x, and to solve it we will split the middle term, we will factorize this equation. So to do that we have to find out two numbers p and q such that their sum is the coefficient of x, which is minus 7, and their product is the coefficient of x square, which is 1, times the constant term, which is minus 60, or this is minus 60. So to figure out what these two terms are, just think about the factors of 60 which differ by 7. So note that 60 can be written as 12 times 5, and this means that the two numbers to split the middle term will be minus 12 and 5, because their sum is minus 7 and their product is minus 60. So let's split the middle term accordingly. So we will get x square, and then minus 7x I will write as minus 12x plus 5x minus 60 equal to 0. Now we can easily factorize this quadratic equation. So from the first pair we take out a common factor of x, so I'm writing it here. So we have x times x minus 12, and then from the second pair we again take out a common factor of 5, so we get 5 times x minus 12, and this is equal to 0. So we have this common factor of x minus 12 now, so let's take that out. So we get x minus 12 times x plus 5, this is equal to 0, and now we can see that the two roots of this equation are x equal to 12, the 0 of the first factor, and x equal to minus 5, which is the 0 of the second factor. Now x was the length of the base of the triangle, so clearly x cannot be equal to minus 5. So this root is an extraneous root, a non-valid root in this case. So the valid root is x equal to 12, and for x equal to 12 the base length becomes 12 centimeter and the altitude becomes x minus 7 or 5 centimeter, and we can see that 12 square plus 5 square will be equal to 13 square. So the other two sides are 12 centimeter and 5 centimeter long. In question 6, the problem statement says a cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. 3 more than twice the number of articles produced on that day. If the total cost of production on that day was rupees 90, find the number of articles produced and the cost of each article. So let's assume one of these unknowns to be the variable. So let's say that the number of articles produced was x on that day. Okay, so let's assume that the number of articles was x, and now we will create a quadratic equation in x. Now the problem statement says the cost of production of each article was 3 more than twice the number of articles produced on that day. So the cost per article was 3 more than twice the number of articles. So twice the number of articles is 2x, and 3 more than this is 2x plus 3. So the cost per article was rupees 2x plus 3. And now we are also told that the total cost of production was on that day was rupees 90. So the total cost of producing x articles at 2x plus 3 rupees per article was 90, and from this we can create a quadratic equation in x. So basically the product of x, the number of articles, times the cost per article, which is 2x plus 3, this should be equal to 90. Now let's write it as a standard quadratic equation. So we'll get 2x square plus 3x equal to 90, or minus 90 equal to 0. Now to solve this quadratic equation, we will factorize by splitting the middle term. So to split the middle term, we need two numbers whose sum is 3, the coefficient of x, and whose product is the coefficient of x square, which is 2, times the constant term, which is minus 90. So this is minus 180. So what are the two numbers whose sum is 3 and whose product is minus 180? So to figure those numbers out, you'll have to think about the factors of 180 which differ by 3, and you can note that 180 is 15 times 12. So the two numbers whose sum is 3 and product is minus 180 are actually 15 and minus 12. Their sum is 3 and their product is minus 180. So this is how we'll split the middle term. So we will write the middle term as, instead of 3x, we will write 15x minus 12x and then minus 90 equal to 0. And now we can factorize this equation easily. So what do we get? So from the first pair of terms, let's take out the common factor of x. So we get x times 2x plus 15. And then from the second pair of terms, let's take out the common factor of minus 6. So when we do that, minus 6, we get 2x plus 15 once again. So this is equal to 0. And now we have a common factor of 2x plus 15. So let's take that out. So we get 2x plus 15 times x minus 6 is equal to 0. And now we can see that the two roots of this equation are x equal to the 0 of the first factor, so that's minus 15 by 2, and x equal to the 0 of the second factor, which is 6. So x was the number of articles, so clearly x can't be this negative non-integer, so this root is not valid in this case. So the number of articles is 6. So the number of articles is 6, and the cost per article is 2x plus 3 or 12 plus 3 or rupees 15. And we can see that the product of 6 and 15 is 90, which aligns with the cost of production given to us.
Thank you for watching our channel. If you like this video, comment, like, share.